Hi, welcome to LeetCode. So in this video, I'm going to discuss LeetCode problem 3468. Find the number of copy arrays. So the problem statement is that you are given an array original of length n and a 2D array bounds of length n cross 2, where bounds I represent ui, vi. So you need to find the number of possible arrays copy of length n such that first one is that the difference between two adjacent value of copy array copy I minus 1 is equal to original I minus 1. So and another condition is that ui less than equal to copy I less than equal to vi. So whatever actually the from original array I will create a copy array, right? So in this copy array, suppose in index value in copy index I, that value should be within the range ui less than equal to value and vi, within this range. Okay, got it? This is the one condition. This is the condition number 2. First of all, that whatever the values I can choose in this copy array, that should be within the range less than equal to greater than equals to ui and less than equal to vi. So that actually I will get from the bounds I, right? And another condition is that, first condition is that whatever the value actually I can choose after this copy array, so the adjacent value difference will be same as the original array difference. So copy of I minus copy of I minus 1, whatever that difference actually have, that will be equal to the original difference, original of index value, that is I, less than equal to original I minus 1. Okay, that should be equal. So now we have written the number of such arrays that is possible to satisfy this condition. Okay, now for this go to the example 1. So original array is 1, 2, 3, 4 and bounds. This represent the first number actually, whatever actually I can choose. So copy of 0, that the copy array length should be same equal to the original array. So copy of 0, that will be greater than equals to 1 and less than equal to 2, right? 1, 2. Next is copy, whatever the index at 1, that value will be greater than equals to 2 and less than equal to 3. Next is copy 2. I can choose 3 to 4. 3 to 4, yes. Then is 4 to 5. 4 to 5, right? Now I have to count the how many actually this copy actually I can actually generate. So first of all, suppose I have chosen this copy 0 at the index copy 0. I have the number actually I have chosen, that is 1. Next from index 1 I have choose suppose 2. Suppose next from copy 2 I have chosen 3. Next from copy 3 I have chosen 4. Okay, now this actually valid or not, how to can actually validate that. First of all, I know that whatever this number I have chosen from the in this copy array, that is actually within the range bound I, right? So now next one I have to check that the difference like original. So here is the adjacent difference is, here actually it is difference is 1. Here actually adjacent difference is also 1. Okay, this is true. Next adjacent difference is also 1. Next in the original, this is still original array. This is the original and this is the copy. This is copy. Here also the 2 and 3 difference is 1. Here actually the next adjacent difference is 1. Here actually the also difference is 1. So this is actually valid. So this is one saga. This is one actually valid copy array possible. Next, what actually I can choose? I can choose, suppose here actually here in this 4 I have chosen, instead of 4 I have chosen 5. Okay, then what is the adjacent difference? Here actually it is 1. Okay, this is okay. Next adjacent difference is also 1. Okay, this is also true. Here actually adjacent difference is 2. In this original in the original array, the adjacent difference here actually 1, but for this the difference is 2, right? So this is not a copy array, right? So in this actually I have to check that how many actually array is possible. Now what actually the steps I can actually solve this problem. So first of all, I know that in this copy 0 I can in the index copy 0 I can choose 1 to 2. right? Next, I know that copy 1 I can choose actually 2 to 3. So, and what actually I have to filter that the difference between copy 0 and copy 1, that should be equal to the difference of original 0 minus original 1. The difference should be equal. Now, suppose I know this is the lower bound, this is the lower value, so I can choose 1, and the higher value I can choose 2. Here is the lower value I can choose 2, and higher value I can choose for this copy 1 3. Now I have to check, I have to take the common values, like what is the difference actually here? Actually, difference is 1. So if I add 1 plus 1, then what is the lower value which I can actually choose from copy 1? At least value, what will be the at least value in the copy 1? That at least value will be at least 2, right? At least 2, I have to, the value should be at least 2 in this copy 1. If I choose 1 from here, then whatever the actual value actually I can choose, that will be 2, right, in the index copy 1. Next, what is the higher value I can choose? Maximum actually I can take in this index 1, that will be 2, and difference is 1, that is I can choose actually 3. So here actually the lower value in this range will be 2 and 3. Now you can see that this is actually the within the range. So I can actually choose here actually the for this copy 1 I can choose 2 and 3 both. Alright. Next, copy 2. What is actually value actually I can choose 3 and 4. Now this is actually the given, but out of this range, what will actually take? I can actually take that actually. I have to check that. What are actually like? It is possible that I can choose 10 to 100 suppose, but here actually the value is suppose 1 to 5. But the difference in the original array, the difference for these two adjacent number is suppose 2. Okay, can I choose any element here in this number? Because maximum value I can choose actually 5. 5 plus 2 suppose. Then I have to take at least 7 in this position. So this is not possible because our range is starting from 10. Got it? Now suppose our range here actually is 15. I can choose 1 to 15 in this position I minus 1. So ith position, in the ith position, what actually value I can choose? Suppose I have taken 1 from this ith minus 1 position. Now what is the minimum value actually choose? Difference value is here actually 2. Difference is 2. Let's it clear. So here actually the range is 1 to 15. And here actually the range actually I can take actually 10 to 100. Okay, so in this number I know that this till this I can actually choose 1 to 15. So I know the difference here actually in this position difference should be 2. So what will actually I can actually take if I take 1, then what should be at minimum value from this position? That should be 3 in this ith position. This is ith position suppose, and this is I minus 1 position. Okay, so I have to take at least 3, but this is 3. Our range is starting from 10. Alright, so what is the lower value which I can choose from this in this position? I can choose at least 10. Okay, and what is the higher value which I can choose from here? Suppose maximum value I can choose here actually 15. So I know that the exit difference should be 2. So I can choose maximum 17. So out of this 10, I can choose only 17. Got it? So that's why I actually optimize our search space or our range. Our range is still greater than actually our minimum number, so I can take. So this is actually 10 to 100, but I can actually take 10 to 17 because I know that our difference should be exact the original difference in the original array. So that's why if I start from 1, I have to take 1 plus 2 3, but our range is starting from here 10, so I can take I can start actually from 10. Okay, this is lower range, but higher range will be what? I can actually maximum value actually in this position I have my previous position, so I can take 15, and so the maximum value from this actually I can take from this next position, ith position, that will be 17 maximum value. Then actually exact difference will be 2, so I can actually take maximum 17. Got it? Now you can check that how many actually number actually I can generate. This is actually 8 array, 8 number actually I can take. Okay, so how? So this actually 1 to 15. Here actually I can take 1 2 3 4 5 in this actually 15. Okay, in this position, ith minus 1 position. This is ith minus 1 position. But in the next position, ith position, I know that I can actually take 10 to 17. Okay, 10 to 17. 10, 11, 12. In this actually 17. So you know that here the starting number is 10 in this ith position. So whatever the minimum value I can choose from this ith minus 1 position, that will be 10 minus 2, that will be 8. This will be actually starting from 8. Actually I can can create a valid copy array. So this will be 8, 9, 10, 11, 12, 13, 14, 15. You can check that how many actually count. You can actually count that 1, 2, 3, 4, 5, 6, 7, 8. Got it? 8 actually valid copy array I can generate out of this. Got it? How actually I'm finding the subset as the common area that actually I can actually take. So what I will do? So I will get one lower and one low range on low and high. Okay. So in ith position, the minimum value low actually I can choose, that will be maximum of the previous low value plus the difference and the new range or bound I comma 0. Right, this will be low actually I can take. This will be starting in this current number because this is the previous low, and I have to take the exact diff. So that will be added previous low plus diff, and it may possible here you can see that our range is starting from 10, but our minimum value so I need actually 3. 1 plus 2, 3. So that's why I have to start from 10 here. Got it? So that's why I'm taking the maximum value. It may possible that our range is starting from the range starting is greater than the minimum value so I can need. Got it? So that's why I'm taking the maximum value. Now what is the higher value so I can choose in ith position? So that will be minimum of the previous high plus diff, previous position high value which I can take, that will diff plus it will added diff. Okay, and it is possible that our range is ending before that will be I will get from index 1 bound of I, and index 1 0 will give the EY and this will give the VI, but ultimately this is actually EY and this is actually VI. So that's why I will take the minimum value. Got it? Previous high, you know, is this clear that why actually taking the here actually for low I am taking the maximum value and for high actually taking the minimum value, because high actually give the maximum range, but possibly our range is ending before that, right? Current range. So that's why I have to take the minimum value. Whatever the actually minimum value, that will actually our common area or common subset. Got it? So in this way I will ultimately at the end after iterating all each element, then I will get one low, ultimately one low and one high. Now whatever the low action high actually I have, that will be give us the total number of copy array, high minus low plus 1. Okay, low suppose pointing 3 and high suppose pointing 5. So this is actually indicating that ultimately after considering all element, our last element can for the last element it will start from 3 and can end with 5. So the total number of actually copy array actually I can generate, that will be 5 minus 3 plus 1, right? This will be one will be ending at 3, one will be ending at 4, one will be ending at 5. So this is ultimately 5 minus 3 plus 1. So this is actually 3. Got it? Ultimately I will get the answer. It is clear? If you like the explanation, if it's clear for you, please like the video, and if any doubt, any suggestion, you will comment on that. Now go to the code. Okay, so code will be, first of all I will find the original array size. Okay, and I know that for the first position our low value will be bound of 0 index and high value will be 0 of 1. Okay, this is actually UI, this is EY and this is VI for this first position. Now for next from next element I have to check that what actually the value I can choose. So this is the previous low and this is previous high. So now I'm starting from I is equal to 1, I will list n I plus plus. So I will get the diff, original I minus original I minus 1. This is the original diff. Now I know that what will new low value, that will be the previous low plus the diff. This will be the minimum low value actually I have to take in this index I, current index I. The number I have to start. Now new high will be what? High, previous high plus the diff, current diff. Now I have explained why should I take the I have to take the minimum value and maximum value. For the low, I have to take the maximum value, and for high, I have to take the minimum value. Now for range, actually check that whatever the new low actually I actually have, and this is actually the for the current number, what will be the EY. So this will I will get bounds I comma 0. So I'll take the maximum value. I have already explained why I have to take the maximum value. This will give the new low. Okay, and new high will be what? The minimum value of the new high. That will be the maximum value. So I have to choose, and the range of the current number, current position, bounds I comma 1. Got it? And it may be possible that if somehow our low is greater than high, that means what? I don't need to go to the further next position, because the current position I can take any element. So that's why I have to return 0. I have to actually validate all the position, not like that last element I have to validate last position only. I have to validate that the adjacent difference is equal to diff. So if low greater than high, that means what? The minimum value I have to choose, that is actually the greater than the maximum value I can actually choose. That's why actually ultimately I can't actually take any element. So that's why I have to return 0 here. Okay, and if we actually get any valid answer, that will ultimately at the end, after considering each element in number of elements, I will get one low and one high. That will indicate the for the last number, what actually the number actually I can start, and what is the number actually I can actually end. Suppose here actually low is 3 and high is 5. So I'll return 5 minus 3 plus 1. So that's why at the end I'm returning high minus low plus 1. Got it? It's clear? I have shared this code in the description. You should check that. Okay. So thank you.